Okay, so how about we finish the rest of 7.1's assignments, right? Wouldn't that be nice? All right, let's take a look at this one. We have, it says express the confidence interval. P is in between 0.444 and 0.888, and we want to write it in the form of P hat plus or minus E. So we're going to need your P hat, we're going to need our E. So to figure that out, let's go ahead and close this out. We use these two little formulas. Point estimate, which is what P hat stands for, um, is expressed as, mathematically is expressed as upper plus lower divided by 2. And we have margin of error, which is the E. That's going to be upper minus lower divided by 2. So very, very similar, right? Basically, we just put the numbers in and we should be okay. So in our calculator, we're gonna have our, let's turn it on. We're gonna have our upper, which is 0.888. We're gonna go ahead and we're gonna add 0.444, hit enter, divide that thing by 2, and that's gonna be your P hat, 0.666. All right, let's go ahead and put that in. All right, so we have 0.666. Let's go back to the calculator. We're going to do the same thing. You can highlight it. You can hit enter. This is for the TI-84s, by the way. Get a TI-84. Go ahead and put a minus, hit enter. We're going to divide this by 2 based on the formula. And that's our margin of error, 0.222. Put this in, so 0.222. And that's it. Excellent. And that's all there is to it for this one. All right, next. Okay, it says express the confidence interval in the form of 0.021, 0.085. This is already written in the form of a confidence interval. Your confidence interval can be written in the form of 2 parentheses. You still have your lower on the left and your upper on the right. And as you can see, all I did was copy and paste basically the 0.021 into here on the left and the 0.085 onto here on the right. And that's it. Get those easy points. That's how you want to do it, okay? So no math involved. I know right here it says P hat minus E. But if you were to figure out the P hat minus E and use the same formulas that we did last time, you know, your upper plus your lower divided by 2, yeah, you're going to get your P hat. But this is telling you to take your P hat and your E. So you do the same thing with your E, upper minus lower divided by 2. And you're still going to get the 0.021. So you can't go wrong either way. But you want to do less work. So I hope you get a lot of these on the exam. All right, next. Okay, it says use the sample data and confidence level given below to complete parts A through D. Let's see, a research institute poll asks respondents if they feel vulnerable to identity theft in the poll. So your N is going to be 1021, your X is going to be 503. It says those who are the people who said yes, use a 99% confidence level. All right, so a few things here. It says find the best point estimate of the population proportion P. So to find the point estimate, that's your P hat. To find your P hat, let's go here. There's another way that you can write your P hat. P hat can be written as X divided by N. Don't we have our X? Our X is going to be 503. So we have 503. And our N is going to be 1021. So go ahead and divide that by 1021. We're going to put that in our calculator. So we have 503 divided by 1021. And this is going to be our P hat. So we get 0.492654, whatever. And how many decimals did they want us to round that to? They just said 3 decimals. So that's going to be 0.49. And remember, we look over here at the 2. We glance over to the right. And to the right of here, we have a 6. And remember, whenever you have 5 or more, you add 1 to it. So this is going to be 0.493. Hit enter, and there's your p hat. Now we're going to do the same thing. It wants us to find the e. Now, there's a long formula to figuring out the e. You take your critical number and you're going to multiply by the square root of p hat times q hat divided by n and all this other crazy stuff. But we're going to use technology, all right? If you're in this course, stick to your technology. You don't want to do all of these things by hand. You have a life, right? I know you don't want to spend all day on this exam. So listen. We're going to take what we learned from the previous example, and we're going to go ahead and we're going to get the confidence interval, and we're going to do upper plus lower divided by 2. Not that it's necessary because we already have our point estimate, our p hat. We want to do the same thing, upper minus lower divided by 2 to get your e. So it's a little trick, not really a trick. We're using our tools to get what we need. Anyway, enough ramble. So let me show you the function. We go to stat, we go to test, and then we're gonna go to one prop z interval. Now, do not get this confused with one prop z test. That's coming up later. That's for chapter 8. Spoiler warning, spoiler alert. But we want one prop z interval is letter number A. Anyway, hit enter on it. They're gonna ask you for your x. Your x is gonna be 503. Okay, anyway. Okay, our n is going to be 1021. Go ahead and put your 1021 in there. Our confidence level is going to be 0.99. Now, you can put 0.99 or you can put 99. They know what you mean. There's only going to be one or the other. So you can put 0.99 or you can put 99. It's up to you. They can tell the difference between decimals and percentages because they know that students make this mistake all the time. So there's a little room for error here. Hit enter. Now, this is your confidence interval. We could use this. We're going to need this later probably, but we want to figure out what is the margin of error. So remember, I'm going to put CI here, and that stands for confidence interval. And give me 1 second. Yeah, so I'm going to say my CI, my confidence interval, is going to be 0.45235, comma, 0.53296. So you know this is your lower, this is your upper, and to find your E, you take the upper minus the lower, and we're going to divide by 2 this guy up here, right? Okay, so let's do it. So we already wrote it down. So during your test, you want to write this stuff down, you know, because the calculator can't store every single thing like that. Anyway, 0.53296. We're going to subtract the 0.45235. Hit enter. Divide that thing by 2. And there's your margin of error right there. 0.0403. All right, so let's go ahead, go back to our window. And let's go ahead and put our margin of error right here. So margin of error is going to be 0.0. How many decimals did they want? They wanted 3 decimals. So 0.040. 0.040. And that should be it. And it is. Well done. Okay, construct the confidence interval. We already have the confidence interval, don't we? Didn't we write that down? Because the calculator spit it right out when you put your X, your N, your confidence level. So we have our confidence interval. We're ready to rock. They said they want 3 decimals. Go ahead and put your 3 decimals in there. And we get 0.452. So 0.452. And we have 0.533. Remember, 3 decimals. Good job. Okay, write a statement that correctly interprets the confidence interval. I'm going to be real with you. They're going to most of the time use the same terminology. So just be very careful as to what you pick. So let's see, one has a 99% confidence that the interval from the lower bound and upper bound actually does contain a true value. I like the sound of that. Um, and I'm right. Hey, if look, it's always going to be in that terminology. Like one has 99% confidence, you have to make a callback to the confidence level that you use. The confidence level was 99, so you have to say something along the lines of one has a 99% chance that the true population proportion is contained within the two numbers or something like that. Just look at this terminology. That the interval from the lower bound to upper bound actually does contain a true value. Yeah, you want to talk. You want that lingo. That's what you want to aim for. All right, next. I already started completing some of these. It says in a study of cell phone use and brain hemispheric dominance, an internet survey was emailed to 2569 subjects, randomly selected. Now, that is your N, that's your sample size. If you ever have trouble knowing what is your N, what is your X, the N is always greater than your X no matter what. Okay. So, um, yeah, it looks like we can go ahead and put everything inside of our calculator. Why not? Just for practice, right? So let's go here. Okay, so we're gonna hit stat. We're gonna go to tests, and we're gonna go all the way down until we hit one prop z interval int. Let's go ahead and put our x. The x is going to be 943. And our n is going to be 2569. So 2569. Our confidence level is going to be 0.95. And don't you just love this technology? We don't have to find any critical numbers like we did in the previous examples. My first video on this. All right, just put 0.95, or you can put 95. If you mess up, you can't go wrong. They know which one you meant. All right, calculate. There's our confidence interval right there. So go ahead and put your, they said 3 decimals, and we're ready to roll. So just like in the previous example, the p-hat is actually listed here, isn't it? 0.367. They give you that in the calculator. Remember, to find your e, the 0.019, you want to take your upper, the 0.3857, minus your lower, which is the 0.34843, hit enter, divide by 2, and you get 0.019. Trust me. All right, but here we just want to go ahead and take what we get from the calculator and put it right in. So 0.348, and we have 0.386. Hit enter. Good job. Okay, so once again, you want to look for that lingo. One has a 90% confidence at the interval. Yeah, it's got to be D. I'm not even going to read the whole thing. Don't even waste your time on it. It's always going to have that lingo. All right, anyway, next. This is fun, isn't it? All right, a random sample of 859 births. Let's go ahead and just put everything in a calculator. We can take bits and pieces of what we need. So, stats, we're going to go over to tests. We're going to go over to one prop z interval. And let's put our stuff in. So we're talking about boys, right? Construct a 95% confidence interval estimate of the proportion of boys. So how many boys do we have? We have 429 boys. How many children do we have? How many births do we have? What is our sample size? Our N, 859. Hit enter. What is our confidence interval? Is 95. Go ahead and enter. Calculate. Bam. There is our confidence interval. They went in 3 decimal places. Go ahead and put your 0.466 and our 0.533, right? Bam, good job. I do these sample results provide strong evidence against that belief. Now here's the thing, I'm not exactly I'm more of a mathematics guy. When it comes to the linguistics and stuff and making sense of it, I'm not gonna lie, I have a little weakness. All of it looks the same to me from time to time, and I'm like, it's kind of a drag. But take your time with it. Who knows? I might get this one wrong. I could get. What's the chances of me getting it wrong? Let's see. Let's see. Do these sample results provide strong evidence against that belief? What's the belief? A random sample. It is believed that among all births, the proportion of boys is 0.508. Okay, our proportion, our p hat is 0.499. So, well, let's see. Is 0.508 in between the interval that we just found? Yes. So I'm Daniel. I am going to say that there is evidence to support that, because that number that they're proposing is within our interval. It's in between 0.465 and 0.532. I'm going to say there is strong evidence. So it's either going to be A or D. Let's see. It's not going to be that one because it is contained. I'm going to choose D. Let's see if I get it wrong. I got it wrong. Wow. Okay, well, we know it's contained within our interval. So it is contained. It's either going to, all right, it's B. It's got to be B. You see how I just worked that out? Why the hell is it B? There is not strong evidence against, oh, not strong evidence against, haha, I should have been reading. My bad. I should have, yeah, the negative. There is not strong, double negative actually. But if I were to see this on the exam, I would get it wrong. And this is the part of learning. Anyway, we're not going to get that wrong a second time. I'll tell you that. Anyway, construct the 99% confidence interval, blah, 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 blah. Okay, so you know the routine. We're going to go ahead and let me see if I turn my fan on. It's kind of hot in here. It's Florida. All right. Yeah, okay. So let me stop recording for a second. I'll be right back. Okay, and we're back. I had to adjust my mic and turn up the gain a little bit so I can pick up my voice a little bit better. We're gonna see. I'm gonna listen to this one again after. All right. Anyway, let's see. In recent tennis tournament, women playing singles, blah blah blah. I'm just gonna find what I need and put the numbers into this calculator. Okay. Stats. We're gonna go over to one prop z interval. You need your x and your n. The n is always the larger number. So let's see. Let me see. 139 calls made by the line judges. Among those challenges, 34 were found to, that's it. The bigger number is your n, the smaller number is your x. So let's go ahead and put your 34 in here. Your sample size, your n is going to be 139. Confidence level is going to be, for part A, it says 99%. Put your 99 or 0.99. And here's our confidence interval. Now take a look at what we have here. Those are percentages. Be extra careful. They're hoping that you just put these numbers in and call it a day. But you want to be very careful with that, all right? So here's what I'm going to do. I'm going to go ahead and write these numbers down. Let me clear this. All right, I'm going to go ahead and write these numbers down. And you're going to see why in a minute. Put 0.5069 and 0.33852. To change these into a percentage, remember something like 100%? Isn't that just 1? It's because the decimal is here. This is like 1.0, right? If you want to change this into a percent, don't you move 2 places to your right? And now you have 100%. It's the same deal here. You want to just basically move these decimals 2 places to your right. So 1, 2, that's going to be, let's put this here now. That's going to be 15.069 now, percent. The minute you move those 2 decimals to the right, it's a percentage. Same thing here, 1, 2. That's going to be 33.852%. So now we have it in percentage form. Percentage form. Now we're ready to rock. All right, so what do they want from us? We have 15.069. You know what you can do as well? You can write that inside of your calculator, 0.069. You know, you can store it in this way. We don't normally do it this way, but You want to use your calculator to the best of its ability and your ability. In 5.2, because sometimes it's best to just have it there where you can always just come back to it, and it's gonna help me out here because I have so many windows open you don't even know. Anyway, one decimal place. That's going to be the first one. Your lower is going to be 15.1, so 15.1. The upper is the 33.9. And that's it. Fantastic. Okay, let's see. Choose the correct answer below. That's a lot of stuff, isn't it? The system. You want to find the one that makes the most sense. For part B, it says compare the results from A to this 99% interval for the percentage made by men playing singles matches. The top was based on women. This new interval, this 21.1% and this 37.9% is based on men. And they are a little bit higher than what we have compared to our interval. But let's just try to make sense of it. Let's see, do they overlap? Yeah, looks like they do overlap. So it could be A, just because the numbers overlap. Like for example, this is between 15 and 33. There is a 33 in between this interval up here. So, to be honest, I'm just gonna guess. And it was right. I didn't even look at the other ones. I just saw the fact that they overlap. They had something that was true about them, and I just went along with it. So just go along with it. I hate to say that. Anyway, statistics is a weird course, as you may have figured out already. Right. Anyway, in a science fair project, given that the Emily used a coin tosses, like what proportion of correct response would be expected? Okay. That's 50%. She flipped a coin. 0.5. Yep. Using Emily's sample results, what is the best point estimate? All right. So point estimate would be your x divided by. Oh, you guys can't even see the question. Okay, sorry about that. I'm sure you're following along when you hit next anyway. But here's what we have. All right. Anyway, using Emily's sample results, what is the best point estimate? Point estimate is x divided by n. So it's small number over big number. I see a 132. You know what? You know they're going to ask us for the confidence interval anyway. They're going to ask us for the confidence interval. So let's go ahead and hit stats. Let's go to one prop z interval. Put your x is going to be 132. Put your n is going to be 288. Confidence interval, confidence level, I mean, they didn't give us one. They didn't give us one yet. Anyway, maybe they'll ask us for 99 again. We'll be ready. But no matter what you put in for your confidence level, your p-hat is always going to be the same. So we know it's going to be 0.58, and that's exactly what I'm going to put here. Yeah, darn it, they use 95, but you know what? It's all good. Stats, edit. Something told me to hit 95. One prop z interval. These all look alike. All right, one prop z interval. Yeah, we just have to change this into a 95. Enter. There it is. So 3 decimal, so 0.401. And this is 0.516. Got it? All right, what do the suggest? Yeah, so you know this drag here. All right, since the confidence interval is not entirely above 0.5, it's not entirely above 0.5. You have that 0.401, so that could be it. So not entirely below 0.5. Is not entirely below. Oh, we have that too. Since the lower limit is below 0.5. Oh, that's true. The lower limit is below 0.5. Since the upper limit is a 0.5. That's true too. All these are true for the first parts of the question. Let's see. What's the subject matter? There appears to be evidence that touch therapists can select the correct hand by sensing energy fields. All right. Identify. I don't know what this is. We get a 50-50 chance anyway. Like, who wants to be a millionaire? And it's sad because Some of this stuff is just drawl, just so unimportant. Maybe it's important to you. I don't know. Let's see. Let's see. When she tested professional to see if they can sense her energy field, she flipped the coin. And she has to identify the name of his name. Let's see. Touch it. Touch it. Right. So they will only write like half of the time. All right. So, these questions tend to want to prove that people are frauds. Since the Lord does not, I'm going to say there is not sufficient evidence. I'm going to say it's either C or A, and we'll just remember it's C. Okay, so since the confidence interval is not entirely above 0, there does not appear to be sufficient evidence. Okay, so if you ever get this question, focus on the part saying it that is not entirely above 50%. Okay, so just focus on that. Adjust yourselves accordingly. Okay. Looks like I already did some of this one. Among 516 human resource professionals, how many of them said that body piercing tattoos were too big? Okay. Oh, this is an interesting one. You know what? I'm gonna show you how to figure this out, and it's gonna be a little technique, a little trick in the calculator. Okay. So here's how it's done. You know, good old trusty stats. You're gonna go to 1 prop z interval. Enter. Okay, it says in a poll of 516 human resource professionals. That's the whole enchilada right there, right? Go ahead and put your 516 for your N. Now, it says 45.5% of that 516 said that body piercings and tattoos were whatever. Okay, so look. We have to figure out what is 45% of 516. That's going to be our X. If you want to figure that out, first of all, you can't just take it like when you're doing 50% of 20, you don't just say, okay, 50% times 20. No, you change it into a decimal first. Remember that? So we're going to change it into a decimal by moving 2 places to the left this time. So we're going to get 0.455. And we're going to multiply by our sample size, which is 516. And I'm going to hit enter, and it calculates it for us. Now, we can't have a decimal. People are, if we're talking about quantitative stuff, right? People are discrete. The number of people is discrete. You remember that from way back when in the beginning? So we can't have a decimal of a person. So you always round up no matter what. I don't care if it's 234.00001. That's going to be 235 no matter what, okay? So we can go ahead and delete this other stuff. So your X is 235. All right, we're good. Okay, 99%. Hit calculate, and there's our interval. 3 decimals, 0.399. And we have 0.512. Okay, same thing, but we're going to use 80% now. So your calculator is so nice. It stores everything that you did in the last step. And all we do is go down here and put 80. And just like that, rather than doing everything by hand, look how fast we got that. It's like, depending on how fast you are with the typing, you can plug in whatever you like and get whatever answer you like in seconds. All right, good job. All right, here we go again. Let's see. A confidence interval must be wider in order to be less confident. Must be wider in order to be less confident. All right, they're saying more confident, less confident. Let's 50-50 this. The 99% confidence. Why? Oh. Well, you know what? Well, we're gonna do a 50-50 because we don't have time for that. It says wider. What does it mean to be wider? That means your upper minus your lower. The distance between them, whichever difference is bigger, that's going to be the one that's wider. So let's take the 0.512, which is your upper. Always do upper minus lower, okay? Minus 0.399. We get that. We're going to do the same thing with the 0.484 minus the 0.427. Which one is bigger? 0.113 or 0.057? definitely the 0.113. That came from the top one. That came from the 99% confidence interval. So the 99 is wider. So the 99% confidence is wider than 80%. So it's going to be B or C. All right, next, let's keep it going. At 77%, this is a lot of homework. Let's see. Yeah, let's get ready to roll. Okay, so stats. Oh, they gave us a damn table. God damn it. And we can't put this in our graphing calculator. But you know what? We're going to use StatCrunch more than likely. Give me a second. I'll be right back. Okay, I'm back. So, yeah, let's take a look at this one again. So, we're going to approach this one a little bit differently. I started to think that we were going to use StatCrunch or something like that, but it's not necessary. And I'm going to show you why. Okay, so remember what we were dealing with? We were dealing with a sample size and then a proportion of that sample size, right? Like a number out of that sample size. So we're basically going to just count one by one of these presidents here. So let's see what we got. And they want us to construct a confidence interval, a 95% confidence interval estimate of the percentage of presidents who are taller. So we want to find the number of presidents that are actually taller than the opponents. So that's going to be our X. While we're here, let's go ahead and go to stats. We're going to go to tests, 1 prop Z, interval. We're going to get our X in a second, but for our N, we're going to put a 20. And our X, remember, they want you to find the percentage of presidents who are taller. So we're only going to worry about who's taller. Okay, so let's see. So if this height over here is larger than the height over here on the right, then we're going to, I guess, tally. We're going to say that that's 1. And we're going to just jot it down. So let's see. This is 1. That's taller. 2, 3. Remember, I'm comparing both of these numbers. This person is taller. That's 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 that were taller. And notice that over here we had a tie, 188, 188. That's not taller, so we're not going to count it. So we have 11 that are taller. So that's what we're going to put here for our X. And we just count it one by one. We didn't have to find any stats or anything like that. And this should work in theory. Let's put 95 for our confidence interval. Calculate. There's our confidence interval. It's a percentage, so don't just willy-nilly just put all the numbers in. You want to move 2 decimals to your right, then put the numbers in. And they said 1 decimal place, so that'll be 33.2. And if you forgot how to do the decimal stuff, you can rewind, right? It's the beauty of having a video. That'll be 76.8. That should be it. And it is. Okay, let's see. If greater height was an advantage, then the taller candidates should have won more than 50% of the elections. You know what? I don't even know. I don't know if the height was an advantage. Let's see. It was over 50% of them because we got 11. 11 is more than 50% of 10 is 50% of 20. We got 11, so that's more than 50%, right? In this case, greater height does not appear to be an advantage because okay, this confidence interval does contain 50%. Yes, it does. Let's see. Let's see. Got it right. I'm not cheating, I promise. All right, let's keep going. Okay, now we're going to do something a little bit different. We're going to find sample size. So find the sample size needed to estimate the percentage of adults who can wiggle their ears. I cannot. My brother can, but I cannot. Anyway, use a margin of error of 1 percentage point So your margin of error is your E, 1 percentage point, and use a confidence level of 95%. Now, sadly, I know, sadly, we're not going to be able to use, there's no calculator function. We're going to use our calculator, but there's no like one prop Z interval, like something like that, like that we could just plug the numbers in. We will, however, I will give you the formula that you need to use. So let's take off this homework thing for us for 1 second. We're gonna go over to our drawing app, and I'm gonna write a fancy new formula for you to use that you've probably already seen. Okay, so your sample size, your N sample size is equal to your Z alpha over 2. Remember that guy? The Z alpha over 2 is going to be squared times your P hat times your Q hat divided by your E. I can do better than that. Your E, and the E itself is going to be risen to the second power. This is your formula. And I think your homework is going to be friendly, and maybe possibly your test. Word of note, if you don't know what this is, if P hat is unknown, if they don't give you some percentage or something like that, if P hat is unknown, you basically treat P hat as if it's 0.5. And do you remember, if your P hat is 0.5, then your Q hat is also going to be 0.5. So this is going to be 0.5 and this is going to be 0.5. Now, if they're both 0.5 and they're going to be multiplying together, basically to give you a whole new formula. It looks very, very similar to the old one. And you can use either one depending on the situation. So we have Z alpha over 2. That whole thing is going to be squared. Now, this is going to be 0.5 times 0.5, right? Wouldn't that be 0.25? So in your formula sheet, like you may have a formula sheet from your book, you're going to see a 0.25 there whenever your P hat is unknown. And down here is going to be E risen to the second power again. And we're going to use these two formulas. So it says find the sample size needed to estimate the percentage of adults who work over years. Use a margin of error of 1 percentage point. Very, very key. Let's go ahead and write this. Very key. That percentage point. That's some important information. So you don't want to get caught slipping. Okay. All right. They said 1 percentage point, right? Isn't that just 1%? But remember, you want to write it as a decimal. So that's going to be 0.01. And remember, for the formula, we're going to raise that to the second power. So if they say percentage point, very important, you want to put 0.01 or 0.01, okay? You don't want to just put a 1 there. It says percentage for a reason. It's a percentage. Please don't catch an L putting just a 1 in there. It's 0.01, okay? All right. Anyway, final sample size needed. Okay, they didn't give us a P hat, did they? So guess what? We're going to use this formula here. We're going to use the 0.25 and put it right in there. So let's go ahead and put 0.25 or 0.05. It doesn't matter. And now, the elephant in the room. The Z alpha over 2. What Z alpha over 2 do we use? If you remember from my previous video, you remember we can just make a histogram and take the inverse norm of just one of those tails, make sure you change it to a positive at the end of the day. Or, because this is one of those percentages that are standard, like for example, I'm going to write CL over here, confidence level. And over here, I'm going to put Z alpha over 2. We have 3 special confidence levels that no matter what, you're going to always get the Z alpha over 2. So there's three standard ones. If you have a 90%, if you have a 95%, and if you have a 99%, basically these are the corresponding critical numbers, critical values. For 90%, you're going to use 1.645 each and every single time. For 95, this is 1.96. And for 99, it's 2.575. Now, if you were a little skeptical and you don't want to commit those to memory, trust me, you're going to want to commit those to memory. If you don't want to commit those to memory, remember what I said? You can do second vars, go all the way down to inverse norm. It's going to ask you for the area. Which area are we doing? We're doing 95%. So remember, make your little histogram. Put your 95 in the middle, 0.95. We want to figure out what those two tails are. So you do 1 minus the 0.95. That's going to give you your alpha. Remember, 1 minus your CL is equal to your alpha. Remember, you don't have to do this. You can just look at this table. We already know it's going to be 1.96, but we're doing this for the people who have inquiring minds. Nothing wrong with that. You do this. So 1 minus 0.95 is going to be 0.0. Let's put it in the calculator. So, oh, you know what? We can put this in the calculator. Well, let me not get ahead of myself. 1 minus, yeah, I'll show you anyway. 195. Hit enter. We're going to divide that thing by 2. We're going to get 0.025. So let's go here and let's go to inverse norm. If you want to, you can put this whole computation 1 minus 0.95, close up the parentheses, very important, divide by 2, is going to give you the answer that we just got. So if you want to, you can put it in just like that. It's a calculator, it calculates. You can go straight to paste and you're going to get the answer. Negative 1.96, remember the trick? I told you that the answer will always come out as a negative, but you want to change it into a positive. Okay, so this is 0.025 right here, by the way, and so is this one. We got this one here, negative 1.96, but we want the positive 1.96. Isn't that what this guy is? So listen, if you ever get 90, 95, or 99, save yourself the trouble and just go ahead and just plug the number in. Okay, for the calculator, remember you second vars. If you went through the trouble of figuring out what that tail is over there on the left or right, you can hit clear. Go ahead and put your 0.025 in there. Go all the way down. Remember, the mean is 0, standard deviation is 1 because we're doing this in terms of z alpha over 2. And you're going to get another negative 1.9. So you can't go wrong. All right. So choose whichever you like, whichever is comfortable to you. Use it and abuse it. Okay. Anyway, let's go ahead and put our, oh, I chose the wrong blue. So 1.96, that's going to be squared. And just very carefully put everything here, just as you see it, parentheses and all, inside of your calculator. Okay. So we have, let's make a little fraction bar to make it easier. To get a fraction bar, I believe it's second alpha, I think it's second alpha window. Let me see if we can get it. Nah, yeah. So second alpha and then window. Let's move over to where it says fraction. And we're going to hit enter right on here. So it gives us a fraction bar. I think there's a simpler way to do it, but I can't remember right now. But anyway, make an open parentheses, put 1.96, close it up. You can hit the square button right here to raise it to the second power. Times, you can put a times if you like. You can put a parentheses. You can get it where we're putting 0.25. It's not going to penalize you for not putting a parentheses. Whenever you're multiplying, you don't have to put a parentheses like that. On the bottom, we have, you can put a parentheses if you want, 0.01. Going to close it up, raise it to the second power, and we get this number here, your sample size, 9604. So now that we have 9604, it came out to be a solid whole number, so we didn't have to round. That's interesting. 9604. Let's put it in and see if they let us get away with it. 9604. Whoops. I got a little trigger. Oh, there's a formula that we just got a little while ago. Finger slip. 9604. Nice work. Assume that 22% of adults can wiggle their ears. So listen, they gave you a p-hat. Whenever they give you a percentage, they're actually telling you what your p-hat is. So, oh, you guys can't see. Yeah, we got the question right. We got the answer right. Okay, Sorry about that. Assume that 22% of adults can wiggle their ears. So that's p hat. So listen, we're going to go back to the calculator. We're going to hit the up arrow here. We're going to hit enter. If you're not comfortable copy and pasting like that, go ahead and write everything down. You can do it from scratch. It's up to you, whatever makes you comfortable. And we're going to hit the arrow so we can navigate back to that 0.25. We want to change that into 0.22 now. So this is 0.22 times your Q hat. Your Q hat is always 1 minus your P hat. If your P hat is 0.22, your Q hat is going to be 1 minus 0.22. Do you remember that? Q hat being the complement of P hat. And this should work. If you wanted to, you could have put in your calculator what's 1 minus 0.22. You get 78, right? Hit enter. Now we have a sample size of 6592.1856. No matter what, we're going to round up. I don't care if there's a 1 there. It should be 6593. Remember, you can't have half of a person or a percentage of a person. Even if they're a little person, they're still a person. All right, so 6593. That's what we're going to put. And I forgot the answer just that quickly, even though I just said it out of my mouth. 6593. 6593. Hit enter. Always round up. All right, next. Another sample size problem. Let's go ahead and handle business. Let's see. All right, so let's go straight to the calculator. This is our placeholder right here. We'll use this. And I like to make life easier. So if you already went through the trouble of getting a fraction bar and everything like that, just copy and paste everything from the previous step. Or you cannot. You can start from the beginning. Anyway, it's using 95% again, so we're using 1.96 again. That's really good. Let's see what else we have. We have 0.22. Did it give us a p hat? Let's see. New York Times, blah, blah, conducted, blah, blah, 336. Because how many adults must be surveyed? Now, if the confidence level is 95, margin of error 1 percentage point. Very, very similar to what we had last time. They didn't give us a p hat this time. Oh, wait, 3.9%. They gave us a p hat. The 3.9% is the p hat. We're gonna find out. Okay, so I'm gonna delete all this stuff. That's the old Q hat, right? This is the P hat. Let's delete that. Okay, move the 3.69 instead of percentage form. Move it 2 places to your left. That's going to be 0.0369. You can take your time. Oh, once again, I forgot to show you guys. Here's the question that we're on, by the way. I'll get it right, I promise. All right, anyway, here's your P hat. You're going to multiply by your Q hat. Make an open parentheses. Do 1 minus whatever your P is. 0.0369. Remember to close it up. It says 1 percentage point again, so that's going to be 0.01 squared. I think we're ready to roll. Hit enter. 1365. Now, I don't know if they wanted us to do this just yet, but we're going to find out. So 1365, we're going to go up to 1366. Oh, they didn't want us to do it yet. Okay. Anyway, they want us to do it without the p hat. So it's basically the same thing that we got up here before, the 9604, because we don't know what it is. So 9604 is using 95. Fantastic. Now use the results from the 2014. Yeah. Now we're going to use the answer that we just got a little while ago. So 6593. Uh-oh. What did I do wrong? Because there's no need. Did I do the math wrong? Oh, it's because I'm using it. I was using the same thing from the previous. Here it is, 1366. My bad. Everybody makes mistakes, right? Anyway, it says, does the use of result from 2014 survey have much of an effect on the sample size? Yeah, that's 9604 in the beginning, and now we have 1366. That's a huge difference. So does it have much of an effect? Yes. So it's either B or D. It's not slightly. No, that's dramatically. This is B definitely. All right, that's it for that one. We're at 90% now. How many more do we have to do? Man, we were on this for a while. I have 2 questions. Anyway, that's good. We made it through. All right. How many randomly selected air passengers must you survey? Okay, so it's the same thing, same routine. They gave us a part A and a part B. Let me see. How many randoms? Okay, so they didn't give us a p hat, so you know what time it is. They give us 99% this time. So let's clear all this crap. So second alpha here instead of window. Fraction 99%. That corresponds to 2.575. You can look at your table in your z-score table. I'm not gonna put a parentheses this time. Sometimes you just know that it's safe to not put one. It's not necessary, as you may know. We don't have a p hat, so we're going to use the 0.25 from that formula. All right, we're going to go all the way down. Let's see, percentage points, 5.5 percentage points. Move 2 places to your left. That's going to be 0.055. Remember, you can always evaluate it from here and move 2 places back to your right. And will you get 5.5? Yes, you will. All right, let's go ahead and hit square. 547 turns into 548. Regardless of what's to the right of it. Now they're going to give us the p hat. So the p hat here is 0.36. So let's go back to our calculator here. We're going to hit enter. And for our p hat, let's destroy this first of all. This is 0.36. Don't want that extra decimal floating around. Be careful of that. If you see that you're getting an error message or something, it's more than likely because you have another decimal. All right, times, we know that's 64, right? 64 plus 36 is 100%. We know it's 64, but let's go ahead and do 1 minus 0.36. Close that thing up, hit enter. 506. You notice this is 505.0. Normally we would look at it and say, okay, we're going to keep it as 505 because it's less than 5 over to the right. 0 is less than 5 right here, right? But no, always add 1 to whatever you got every time. All right, 95%, feeling good. All right, I think this should be the last one. Finally. All right, let's see what we got. All right, let's keep going. 95%, so you know we're going to use 1.96 for your critical. Your Z alpha over 2 is going to be 1.96. Yeah, let's go ahead. Second alpha, let's clear all this. Second alpha, y equals, yep. All right, so we're going to use 1.96 again. So are we? Is that 95? I'm losing my mind. Yes, it is. 1.96. We're going to square that bad boy. They didn't give us a p hat, so 0.25. Let's see what those percentage points are. 8 percentage points, so 0.08. We're going to square that thing on the bottom. Hit enter. 151. Back in my day, there were only 151 Pokemon. Now there's, I think I'm showing my age. Anyway, assume that a recent survey, 84%, same routine. We're going to go back, change that p hat, change it to 0.84. We're going to multiply by, make a parentheses. Always make a parentheses when you're adding and subtracting. 1 minus, since we're subtracting something, you want to have a parentheses outside. 1 minus the 0.84, what is that, 16, right? So we're still going to put 0.84 here. Enter, enter. I didn't have to hit enter twice, but yeah, finger slip. 81. Oh, this crap. Okay, given required sample size is relatively small, could he simply survey the adults at the nearest college? I don't know. Let's try to make sense. Yes, so sample. Let me see. No, it's convenient. I think it is a convenient sample. When it says nearest, I'm feeling that. Trust me, that when you see if you see the same exact question, just choose the nearest thing that says no. Okay, I think we're done. We have 100%. Great job. Thank you so much for watching this. The next video is going to be 7 point something else. It's going to be the other one. I'm not sure if it's 7.2, but yeah, I'm going to put this together really quickly. Hopefully, I think you guys will be asleep by the time I upload this. But yeah, see you in the next video. Thank you for watching.